This lesson is entitled Quadratic Functions, and we'll be graphing quadratic functions in several different forms, in general form and in standard form. When we talked about our transformations and functions, we also transformed quadratic functions, but today is going to be a more in-depth look at quadratic functions because they do appear more often than some of the other functions. We need to know just a little bit more about them. Our quadratic function in general form can be written f of x is equal to ax squared plus bx plus c. The quadratic function in standard form is written f of x is equal to a times x minus h quantity squared plus k. We graphed when we were transforming functions from standard form, f of x equals a times x minus h quantity squared plus k, where the a was the compress or stretch. The a, if it was negative, was also a reflection. The h was our horizontal shift. It was also the x-coordinate of our vertex. Our k was our vertical shift. And the y-coordinate of our vertex, or turning around point. So from the transformation section, we knew we took this quadratic function here. We transformed or translated the vertex to some new hk. And then we sketched the rest of the graph by using the a. The a, if we went right one and up a, and left one and up a, we got 2 more points, and then we could sketch our new graph, translated and possibly stretched or reflected or compressed. And that's how we did it in transformations of functions. We're going to be doing a little bit of the same thing, although I'll be asking you to find some more information like the x-intercepts, the y-intercepts. We're going to be talking about the axis of symmetry, the domain and range, and maxes and mins. First, let's take a look at these graphs where each graph's vertex is 0, 0. Now notice what a does to the graph. In this particular problem, we have a is equal to 1 because there's no coefficient in front of x squared. I could go right 1 and up a, or I could go left 1 and up a. That got me 2 more points plus the vertex, and I can get a pretty good graph from that. On the second graph, my a is 2 because the coefficient in front of x squared is 2. So from my vertex, I can go over 1 and up 2, and left 1 and up 2. Similarly, on the third one, I have a is equal to a third. From my vertex, I can go right 1 and up just a third, and left 1 and up just a third, and that got me 2 good points. Notice on the next problem, f of x equals negative x squared, my a is actually negative 1. So from my vertex, I'm going right 1, and instead of up 1, I'm going down 1. This is a reflection over the x-axis. On this next problem, I have a being negative 1/2. The negative tells me that I'm pointing down. The 1/2 tells me that from my vertex, I'm going right 1 and down only a half. Left 1 and down only a half. Down because it's negative, a half because that's my value. On my last one, I have negative 3x squared, where my a is negative 3. From my vertex, I'm going right 1 and down because it's negative 3 units, and left 1 and down 3 units. These are going to get me at least 3 good points. If you have the vertex and you have the a, you can get at least 3 good points. Your x-intercepts, your y-intercepts, and any other values you may find can get you an even better graph. Next, we'll look at the steps to graph from standard form. Notice there's 8 steps here, and we have graphed quadratics with less than 8 steps here before in the previous sections where we were just talking about transformations. Some of these steps you may not be asked for every single time especially steps 5, the axis of symmetry, and 7, the domain and range, and 8, the max and min. But in this video, I will be finding all of the values for every single problem, even though when you go do your homework, you may not have to find every single one of these for every single problem. Just make sure that you're reading the instructions on your homework so that you understand what's really being asked. And I'm going to be doing probably more than what's asked for each problem here. But that way you'll understand, so when you get to each problem, you'll know what you need to do. So first step is to identify your A, your H, and your K. Notice that this equation is already in standard form. We will talk a little bit later about what to do when it's not in standard form, but in this case we're going to start from standard form. My A is the coefficient in front, which is 1. The H is -3, or the opposite of the inside, and the K is +1. Notice the inside the parentheses has the opposite sign, where the outside of the parentheses does not have the opposite sign. To get the vertex, we say H, which is -3, the opposite of the inside, comma the outside, 1. So from here, I could probably jump down to step 6 and graph what I already know. -3, comma +1, I already have a point. I could use my A to get at least 2 more points. My A is a +1, so from my vertex, I can go right 1 and up A, which is 1, and left 1 and up A, which is 1. I have at least 3 points. That's going to get me a fairly good graph, but I'd like a little bit better graph on this particular problem. So I'm going to keep doing my steps, and I'm going to find the x-intercept. In order to find the x-intercept, I set y equal to 0 and solve for the x-coordinate. So in my particular problem, the y, or in this case f of x, is equal to 0, x plus 3 squared plus 1. When I subtract 1 from both sides, I get -1 is equal to x plus 3 squared. Then I take the square root of both sides to get x plus 3 all by itself equals plus or minus the square root of -1 is I. Well, can I graph an x-intercept with an I in it? I could go one step further and solve this to get x is equal to -3 plus or minus I, but really this is not helping me at all. I can't graph an I value on my xy grid, so I'm going to cross off the x-intercept and write none. Now I probably could have looked at my graph and already known that it was none because my vertex is above the x-axis. My A is 1, which means I'm pointing up. I already have these 3 points, and I can clearly see that this parabola, or quadratic function, is not ever going to hit the x-axis. Did you have to do all this work to figure out if there was no x-intercepts? Not really. You could have just looked at the graph, which is why I sometimes sketch my vertex and use my A to get some points before I actually find the x and y intercepts. It might save me a little time, and I'm all about saving myself some time. To get my y-intercept, I'm setting x equal to 0. So when I try to find x is equal to 0, I'm really just finding f of 0, which is 0 plus 3 squared plus 1. 3 squared is 9, 9 plus 1 is 10. So I found another point, 0, comma 10. Next, I'm looking for the axis of symmetry. Well, you have a symmetry line in each quadratic equation, and the symmetry line is a vertical line that passes through your vertex. The vertical line is always written x equals some number, and x equals, in this case, -3. So I have an axis of symmetry here. Why is that helpful? Well, if I notice that I have an axis of symmetry, I have one extra point on the right-hand side, my y-intercept at 0, 10. I can use this one point and reflect them over the axis of symmetry to find another point. The green point is 1, 2, 3 units away from the axis of symmetry, so I'm going to travel 1, 2, 3 units on the other side of the axis of symmetry, and now I have 5 good points so I can sketch my graph, which is a much more accurate graph than I've had in the past sections when we were just talking about some transformations. On some of the problems, you'll be asked to find the domain and the range. We've done this before in the past, so I'm just going to do it exactly the same way. Whenever I have an arrow pointing to at an angle, I'm going to break it up into its vertical and horizontal components. I'm looking for the domain. My arrow says I'm going left forever, and I'm also going right forever. So that tells me that my domain is going to be all real numbers, negative infinity to positive infinity. Well, my range goes up forever and it goes up forever, although it does not go down forever. How low can it go? Well, if you start from the bottom, the first point you can have on your y set is positive 1, and it goes up and up and up and up and up forever. So my range is going to be 1 at the lowest, I'm including it, comma infinity, it will go up forever. Looking at all quadratic functions, you either have a low point at the vertex or you have a high point at the vertex. In this problem, my parabola comes down and it has a low point here at this vertex at negative 3, 1. This is the lowest point of the entire graph. So therefore, I'm going to have a min value. I'm not going to have a max value. So that's what it means, min or max value. In this case, you have a min value, so you don't want to consider the max at all. There is no max, it goes up forever. What is the min value? Well, the minimum value you can have is the y value, which is 1. So my min value is 1. Then sometimes they ask, where does that min value occur? Well, the min value of 1 occurs at x equals negative 3. And this is all the information that you'll be asked for on any type of problem that you'll see in this section, given the equation is given in standard form. Let's talk about these steps one more time. If you're trying to find the a, h, and k, it needs to be in standard form. The a is in front of the coefficient, the h is next to the x being squared, and the k is on the outside. The vertex is always going to be h, k. Your x-intercepts are found by setting f of x equal to 0 and solving. Notice we set f of x equal to here and we solved. We got none in this particular case, but that's how in general you would do it. In order to find the y-intercept, we evaluated f of 0 to find the y-intercept, and it's always written 0, some number. To find the axis of symmetry, well, the axis of symmetry is always a vertical line, so it's always going to be x equals, and it's always going to be the x-coordinate of your vertex, and the x-coordinate of your vertex is always going to be h. So your axis of symmetry will always be x equals h. Next, we graphed our information and asked to find the domain and range. Well, for quadratic functions, domains and ranges have some common patterns. My domain is always going to be all real numbers. It has no excluded values from the domain because we don't have a rational function. We also don't have an even root function. So there's no values that are ever going to be excluded from the domain. My domain will always be all real numbers for quadratic functions. The range could be one of two things. Either we have a parabola pointing up or a parabola with its arrows pointing down. If we have a parabola with its arrows pointing up, we have a low point at the y value, k, but it goes up forever. But if you have a parabola with its arrows pointing down, we go down forever, and the highest point we can be is the y value of the vertex, which is k. Also, it's interesting to note that when your arrows are pointing up, you have a min value, and when your arrows are pointing down, you have a max value. How do you find that max value? Well, the max value is always the k value. Where does it occur? Well, it occurs at x equals h, and that's going to be your max or your min, no matter if you're pointing up or down.